Okay, let's work through a couple practice problems within our What's Up packet, starting out here with cross-section number 1. Most important thing to recognize here is how many events should we have in the directions. It tells us that we should have 6 events. So that's what we're looking for. Starting with number 1, working our way up to 6. Now we know the best thing to do, thinking about our cross-section, is to start out with the oldest rock layer, and the oldest is typically, of course, on the bottom. Now here I only have one option of the bottom rock layer, and that is the sandstone, so I'm going to put a number 1 there. It's got to be the oldest. Now remember, I'm not only numbering layers, but I'm also numbering events, so I have to keep in mind, do I have folding, faulting, tilting, or an unconformity? My second layer from the sandstone, working my way up, is going to be the conglomerate here. Okay, this is a layer of both pebbles and sand, sedimentary rock. As I work my way up, before my next layer can appear, I know this dark wavy line gives me a clue that this is an erosional surface. So I want to label that as 3, and this is a contact of erosion. So I'm going to give that a name of an unconformity. Again, working my way up, looking for 6 total steps. I've got to have a 4, 5 right above that, and then my 6 is that erosion on the surface erosion. Once the numbers are in place, I need to write my history for this cross-section. Each layer, of course, I'm going to use my rock key for. Okay, the first one was already done for you. If I was doing the conglomerate, number 2, I'd be thinking something like this. Deposition, compaction, and cementation of sand and pebbles in a mountain stream environment creates, and then I would end with the rock type, conglomerate. And again, all that is coming right from the rock key. Reading left to right of all the steps needed to make that rock type. When I'm looking at 3 and 6, my erosional surfaces, I want to then talk about what has to happen in order to create those unconformities. So if I'm talking about history step number 3, looking at my unconformity notes section, I see that chart there on the bottom to guide me left to right again how to make this event occur. Starting out with weathering and erosion. And then I have to say what layers are affected by that weathering erosion. So I'll say of layers. And looking at the cross section here, number 3 comes in contact with both 2 and 4. But I know it can only erode layer 2 because 4 didn't exist when 3 came in, giving our numbers for relative time. So weathering and erosion of layer 2 creates, and then I have to look and see what type of unconformity would this be. I have 3 options: disconformity with 2 sedimentary rocks, nonconformity with igneous on the bottom, or the angular unconformity. And I can tell right away from the picture, because these are not tilted, angular is out of my choices. Knowing that conglomerate is a sedimentary rock, I'm going to name this a disconformity. Okay, so those are 2 examples of the 6 history sentence needed for example number 1. As I work my way to number 2 here, I'm seeing something new that I didn't have last cross section. I have these 2 igneous intrusions. So I'm going to be thinking a lot about my cross-cutting rule as I go through the slide today. Again, starting out with my oldest on the bottom, I have a few choices now. I not only have this limestone layer, but I also have the basalt and the granite hitting the bottom of my cross section. So what's it going to be? Knowing my photobomb rule, I know that this limestone layer had to exist first before these other 2 could appear. So limestone has to be my number 1. And because both intrusions, again, cut into this second layer, I know this has to be my number 2. So I've got limestone 1, shale as 2. Now I have to figure out where do these intrusions come into play. Photobombing rule tells me they have to come after those 2 layers because I can't cut through nothing. But now, this one I know is older than my basalt. Basalt goes through pretty much every layer that exists here. Okay? Whereas this guy only cuts into these 2 layers, so he has to come sometime before I start to number the top layers. This is definitely going to be my layer number 3. And my wavy line here is going to be erosion, step number 4. I know that the erosion had to come after the granite because I can see the granite was eroded, right? It was cut down here. So the erosion happened after the granite came in. Once I have my erosion labeled as 4, that leads me to the conglomerate 5, the sandstone 6. I have 2 layers left. I have either my basalt or my erosion. Thinking about what I looked for here, I noticed that this basalt is a perfect volcano. There's no erosion happened yet on this basalt volcano. So that tells me here the top layer had to be 7, whereas the basalt intrusion had to be number 8, 7 being the surface erosion. Okay, so again, now that I have all my layers labeled, I've got to start working in the history. The layers 1, 2, 5, and 6, those will all look the same as the example that we did in number 1, reading across on your yellow rock key. 4 and 7, those are going to be just like the practice problems that we did on example number 1. Weathering and erosion of layers gives me what kind of unconformity. Here's the new ones, number 8 and number 3. So let's work the number 8 together. Because it is a rock layer, I'm using my rock key, and I see that this is a layer of basalt. So I know that basalt is coming from lava, because it is an extrusive rock, and I see on the chart there, I'm just going to read left to right. Lava extrudes, of course, then has to cool and crystallize. And because it's lava, this is happening on the surface. But I also have to say what layers it went through to get to the surface. So I'm going to say through layers. And now I have to look. What layers did this basalt cut into? It cuts into layer 1 and layer 2. I don't count layer 3 because it's way over here, not impacted by the basalt. So I've got 1 and 2. 4 here is not a layer, it's an unconformity, but 5 and 6 are also layers, so I'd like to list those as well. And I simply end by following the table to say forms basalt. I would do a similar sentence for my granite intrusion here, but now saying it only cuts into layers 1 and 2. Feel free to pause the video at any time, work through your history, then pick back up when you're ready. Looking at cross-section number 3, the directions tell me that I have 7 events I need to fit in. Layers and events. We should notice first there's one pretty big event happening in this picture, and that is folding. So I got to make sure I add that in to my history. Okay? Again, starting at the bottom, I have to think about what happened first, the layer at the bottom or the fold. Now I can't fold layers that don't exist, so I know this layer had to appear first. And folding is what makes these nice wavy lines happening in the cross section. So if I look carefully, I can see that all the layers present here were folded. So I'm going to start out by simply labeling all my layers. 1, 2, 3, 4, 5. There are 5 layers here that are impacted by the compression of the fold. So because the layers had to exist first, all I have left is folding, and then my erosion on top. Okay, now thinking about this, what happened first, the fold or the erosion? Well, I should see a little bit of this layer here along with the next layer on top, but those layers are gone. They've been taken away or eroded. So I know that folding had to happen first and that erosion last. So I'm going to label all of this as step 6, the event of folding, and my last one, layer 7, this is my uneven surface erosion. Okay? Now it does ask you to write the history of folding. Use the chart on the front of the packet where we see the picture of the fold, and just simply read it from left to right, writing it in as practice. Working across section number 4. Same thing, I have to notice what my big event is. I have 9 layers and events to label. Hopefully you can recognize that there is some tilting going on in this picture. And I also have an unconformity. Okay, again, I have to decide what happened first, the tilting of the layers or the layers themselves. I know the layers had to be there first before I could tilt them, so I'm going to start at the bottom. Now I have a lot of choices down here for the bottom. Knowing that the layers had to start horizontal, I can tell that this was my oldest layer. And again, looking at how many layers were tilted, I can figure out where the tilting step comes in. So I've got number 1, 2, 3, and then 4. All those layers have been tilted, no other ones are, so tilting must be my next step. So all of these layers being tilted should be step number 5. I know the tilting happened before this erosional line because look, the layers are cut off. I don't see them going off into space anymore. So the layers got cut off. So here is my erosion as 6. Leaving my conglomerate here as 7, sandstone as 8, and my surface erosion to be number 9. Okay, again, there are 2 steps for you to put in your history here. Those 2 steps are numbered as 5 and 6, so go ahead and write in your steps for both tilting and this unconformity. And looking at the picture, make sure you label it as the correct type of unconformity with the tilted layers on the bottom. Last cross section here, number 5. Looking at the directions, I have 6 events that I need to put in to my cross section. We should notice right away the big event here is, of course, this. This crack in the Earth's surface has caused the layers to become offset. This is a fault. I've got to figure out what number is the fault going to be. Now again, I have 6 events that I need to number. How many of the layers are affected by the fault? 1, 2, 3, 4. All 4 layers are cracked through, so I need to take that into account when I figure out what the fault is going to be. Again, thinking through the thought process, what had to happen first? The crack itself or the layers? Now, of course, I need to have the layers there before the crack can cut into them. It's my cross-cutting rule. So this layer is cracked, it's got to be there first. Got to be there second. Third, this one's also cracked, as is the layer on the top. Now I have the fault left and my surface erosion. I've got to figure out which came first. Now the purpose of erosion is to create an even surface, right? Completely flat. But what I see here is this bump. So that tells me even the surface was cracked. So the erosion had to be step number 5 and the fault had to be completely last at step number 6. Each one of these cross sections has kind of one big event happening in them. As you advance forward, keep these rules in mind, but now we're going to see multiple events happening in each picture. Good luck.